All right, within the next section here, we're going to look at the division of radicals. There's going to be several examples we'll go through here. So I'll have the video done by section so you can easily go through it. And you might need to probably take some time to take this one in. All right, first off, so there's four main types we're going to go through here. So in section A, we're going to look at where radicals divide evenly. And what I mean by when radicals divide evenly, well, the numerator and denominator can divide into each other and you don't have any difficulty with it. So, well, I should say any, or very little. So look at number 1. So you have root 12 divided by root 6. When you're dividing radicals, you can divide both the radicands. So the numbers underneath the radical sign, you see if they can divide into each other. So 12 divided by 6. Well, or 6 goes into 12 2 times. That's it, as far as you can take it. Over here, root 2 divide into root 24. Well, 2 goes into itself once, and 2 goes into 24 12 times. So it leaves you with square root 12. And the square root 12, you need to simplify that. 4 times 3. Square root 4 is 2. And root 3 cannot be done. So this one is your answer. And some of these you're going to have coefficients. So 3 divided into 12. So 3 divides itself once. Divides into 12 4 times. 7 goes into itself once. And into 56 8 times. So in the numerator, you have 4 root 8. And here you have 1 times root 1. Root 1 is just 1. So root 1 will give you 1. So 1 times 1 is just 1. So the denominator here is really just a 1. So that's why we don't write this in here. So you may have been wondering that from one of the previous questions there. 8, well, is there a perfect square that divides in 8? Well, there is. 8 is 4 times 2. Square root of 4 is 2. So let's work with the first 4. That's already there. The square root of this 4 is 2. So that comes out from the radical sign because you can simplify it. And then the square root of 2, this one, stays there. You can't simplify root 2. So the overall answer is 8 root 2. Here in section B, the denominator divides, denominator simplifies to divide evenly. All right, let's start with number 5 here. So look at your coefficients, 4 and 2. Something to point out here is that this 2 right here can never divide into that 40. So the coefficients divide into each other and the radicands divide into each other. There's no crossing, no mixing of that. So 4 divided by 2 is 2. And then square root 40 divided by square root 18. Well, you don't get that right away, so you have to do a little bit of work here. So what number can divide the both? Well, the number 2 can divide the both. 40 divided by 2 is 20. And 18. 18 divided by 2 is 9. So there's times when you just divide them out. I mean, this works no different than if you had 40 over 18. Just that now we're putting in radical signs. So it would still simplify that to 20 over 9. So the math part of that, the division stays the same. So here's what we're saying: the denominator simplifies to divide evenly. So the denominator is going to simplify. So you get 2, and the root 20 can get worked out, but let's talk about that in a second. Let's just focus here on the denominator. So 2 root, and we're going to deal with the 20, over root 9. Well, square root 9 is 3. 20 is 4 times 5. Square root 4 is 2. That will come outside and multiply to the 2 that is already there. So you're going to have 2 times 2, root 5 over 3, or 4 root 5 over 3. Let's pick number 7. All right, so you have 12 over 9. So we're looking at just the coefficients first. Both these could divide by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So you get 4 over 3. Now we'll look at our radicals. Square root 72 divided by square root 24. If you're not sure what divides in, just see if the denominator can divide into the numerator. Can 72 be divided by 24? And it can. 24 goes into 72 3 times. That's it. Done. Can't simplify that one any further. Next, section C. This is where you have to rationalize. So rationalizing will be, I think, a new step for you. So you rationalize the denominator. So one of the rules when you're dealing with radicals is that a radical sign, in this case square root, cannot be left in the denominator. So remember, in fractions you have a numerator and you have a denominator. So root signs cannot be left in denominators. You couldn't leave this as 1 over root 6. In order to fix this, we're going to multiply it by 1. Now you might be thinking, how is multiplying by 1 going to fix this? Because it would just get back 1 over root 6. Well, the trick is that this 1 gets written in a slightly different way. What we do, whatever this root is, we make it a fraction and we multiply it to the original question. So here's what we've done. We've taken this root 6, made it a fraction where it's a numerator and denominator. So how's this multiplying by 1? Because I said we were going to multiply by 1. Well, root 6 divided by root 6, same number divided by itself, is just 1. So you haven't changed the question. Mathematically, the question is still 1 over root 6, or the expression. All right, so what has this done for you? Well, 1 times root 6 is root 6. Root 6 times root 6. If you remember from the multiplication section, is that you multiply those terms underneath radical signs. In other words, the easy way of saying it is both are roots, so you multiply them together. 6 times 6 is 36. Square root 6 over 6. That's your answer. This step is called rationalizing. Because now the numerator is a rational number, and we talk about that in class rather than getting into a whole discussion here about rational numbers. All right, let's look at number 4. So 8 root 2 times 3 root 5. 8 and 3 can't divide, 2 and 5 can't divide. So to rationalize, you take the root in the denominator and you make it a fraction. Or make a fraction out of it. Okay, so from the multiplication section, we know that coefficients multiply. So you have 8 times, and the number that's here, even though we don't see it, is a 1. So 8 times 1 is 8. Then you have 2 times 5, 10. 3 times 1 is 3. Root 5 times root 5 is root 25. 8 root 10 over 3. Square root 25 is 5. So 8 root 10 over 15. And you can't take 8 and divide into 15. You may also notice a shortcut by now. Is that when you take the same radical and multiply to itself, you end up with the radicand. So whatever number's underneath. So if you say root 5 times root 5, yeah, it's root 25, but square root 25 is 5. Over here, root 6 times root 6, well, that just turned out to be 6. All right, last part. So in section D, where the numerator is 2 terms. All right, so it's 2 terms in each of these questions. Here's one term, here's the other, root 8, root 20. We can't subtract them or add them or do anything like that because they are not the same term. This is root 8, that's root 20. Can't subtract them. Okay, but this is all over root 2. I could take the root 2 and divide into both of these, but it has to go into both. If it can't go into both, then you can't divide. So 2 divides into 8 leaves me with 4. 20 divided by 2 is 5. Square root 4 you can do. So that's 2 root 5 you can't. So you have to take the denominator and see if you can divide into both terms. So let's try number 3. 2 can divide into 6, yeah. Now if this were like a 9, okay, let me just change this question. So you had 2 divided into 6, can 2 divide into 9? No. So you wouldn't be able to do that, okay? This 2 can't divide that. So you'd have 6 root 10 plus 9 root 2. Like you can't work that out. What you could do, you could take this root 2 and divide into both the 10 and the 2. And that would leave you with a 5. And 2 divided by 2 is 1. So you have to be careful. Make sure you can actually divide it. And it would all be over 2. But that's not our question. So can this 2 divide into both coefficients up in the top? And it can't. 6 divided by 2 is 3. 8 divided by 2 is 4. Let's put a plus sign here. Now you have the root 2. Here. Can that divide into 10? And it has to go into both. It has to go into 10 and the 2. So root 10 divided by 2 is root 5. And root 2 divided by root 2 is just 1. It cancels. So your answer is 3 root 5 plus 4. Okay, I think that's long enough. Anything else we'll take care of in class.